If you left Earth tonight, the first thing that would disturb you would not be the darkness. It would be how quickly Earth stops looking endless. From the ground, this planet feels too large to understand. Oceans take days to cross. Mountain ranges split weather systems. Cities glow through the night as if they are permanent. Human problems feel massive while you are standing inside them, because from the surface is everything. Pull away from it, and that certainty begins to break. The noise goes first. Not because sound fades in some dramatic way inside the spacecraft, but because the whole idea of ordinary life starts to feel sealed below you. Roads, airports, hospitals, kitchens, arguments, alarms, offices, bedrooms, all of it remains down there, pressed against a curved planet that is already becoming an object in your window. A little higher, the borders vanish. No country announces itself from orbit. No argument draws a line bright enough to be seen from space. Clouds move over everything with complete indifference, and the atmosphere becomes a thin blue edge around the planet, so delicate that it looks less like armor and more like a temporary agreement between life and vacuum. That would be the first real shock. Earth does not look protected by space. It looks exposed inside it. All the air anyone has ever breathed is held close to the ground by gravity. Every storm, forest, city, ocean, voice, and living body exists inside a narrow layer wrapped around rock and water. From above, the world does not look like the center of anything. It looks like something that has survived. If you looked carefully at the dark side, you might see something even stranger than city lights. A faint glow can sometimes trace the edge of the planet. It is called air glow, a weak natural light created high in the atmosphere. From the ground, it is easy to miss. From above, Earth can seem to have its own quiet outline, a thin living border between the surface and space. Sunrise would not arrive the way it does from the ground. It would not slowly brighten a room or touch a window. It would appear as a blade of light crossing the curve of the planet. Night would retreat across oceans. Clouds would turn gold at the edge. Cities on the dark side would keep glowing for a while, little nervous sparks scattered over the black surface. Nothing down there would look as loud as it feels from inside. The moon would be waiting nearby, but the word nearby becomes strange very quickly in space. It is close enough to shape Earth's tides, close enough to dominate our night sky, close enough that human beings have walked there. At the same time, it is far enough away that the distance can swallow Earth completely if you try to imagine crossing it without machines. From home, the moon feels familiar. It follows you down empty roads, hangs above rooftops, reflects in water, and becomes part of the emotional furniture of human life. Travel toward it, and the softness disappears. The moon is not a lamp in the sky. It is a dead world close enough to follow us. Its surface would look gray, dry, sharp, and old in a way Earth almost never allows. There is no blue sky to soften the light, no air to blur the horizon, no weather to hide old damage. Shadows would look deeper than shadows on Earth, because sunlight is not scattered through an atmosphere. The line between brightness and darkness would feel harsh, almost cut into the landscape. The horizon would also feel wrong. Because the moon is much smaller than Earth, the curve of the world is tighter. The horizon sits closer. A landscape can feel vast and cramped at the same time, as if the whole world is large enough to be a planet, but small enough to remind you it is not home. Craters would stop looking decorative. Each one is the remains of an impact that stayed visible because nothing came later to erase it. Earth keeps editing itself. Rain wears things down. Wind moves dust. Oceans grind coastlines. Plants cover scars. Plates shift. Volcanoes rebuild. Ice carves. Life spreads over damage and makes it look natural again. The moon keeps receipts. Flying low over its surface, you would pass old volcanic plains, mountains raised by impacts, and basins so large they no longer feel like holes, but like chapters from a violent beginning. Somewhere in that dust, the Apollo footprints would still be there. That fact has become familiar, but it is still difficult to absorb. On Earth, a footprint is one of the weakest marks a person can leave. It disappears under wind, water, traffic, or time. On the Moon, a boot print can outlast cities because the world around it has almost no way to forget. Leaving the Moon behind, Earth and its companion would begin to look like a pair, a living blue planet and a silent gray witness, bound together, moving together, both falling around the Sun. That is when scale begins to do real damage to the imagination. The solar system is usually shown as a clean line of planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. The images are useful, but they teach a quiet lie. They make the solar system feel crowded. A real crossing would feel nothing like that. Most of the journey would be empty view. Instruments would know more than your eyes. Long stretches would pass with no dramatic object nearby, no planet filling the window, no asteroid field rushing past like a movie. Space would be dark, patient, and too large to perform for you. Turning inward toward the Sun would change the mood immediately. The Sun is easy to misunderstand from Earth because distance makes it kind. It becomes morning, warmth, weather, crops, open windows, a gold disk behind clouds. We live at the exact kind of distance where a star can be mistaken for comfort. Closer in, that idea would fall apart. The Sun is not a lamp. It is a violent star that happens to be stable enough, from far enough away, for life to build routines around it. Its surface would not look solid. Plasma would churn. Magnetic fields would twist. Loops of glowing material would rise and fall in shapes larger than planets. A solar flare would not feel like an interesting event on a science website. It would feel like the star reminding you that everything in the inner solar system lives under its temper. More than 1 million Earths could fit inside the Sun by volume. That number is too large to feel properly, but the view would help. A world that once felt endless would become small enough to lose inside the thing that lights it. Near the Sun, you would understand something diagrams rarely make emotional. The solar system is not centered on light. It is centered on force. Every planet is falling around the Sun. Every comet has its path bent by it. Every orbit is a long compromise with gravity. The Sun is not sitting politely in the middle of a model. It is holding the entire structure together. Mercury would be the first planet to appear, a small gray survivor moving too close to the engine. People often assume the closest planet to the Sun must simply be the hottest, but Mercury is more interesting than that. It has almost no atmosphere, so it cannot keep heat in a gentle Earth-like way. Sunlit regions can become brutally hot, while places in darkness can freeze. Some of Mercury's polar craters may even hide water ice. That sounds impossible until you picture the geometry. Near the poles, some crater floors stay in permanent shadow. Sunlight never reaches down into them, so ice can survive inside darkness on a planet that orbits closest to the Sun. That is the kind of contradiction the solar system keeps creating. A world can be scorched and frozen at the same time. Flying over Mercury, you would see craters everywhere, along with long cliffs crossing the landscape. Those cliffs formed as the planet cooled and contracted, leaving wrinkles in rock. It is a small world with the history of its own shrinking written across its face. The Sun would look huge from there, not romantic, not golden, dominant. Mercury feels like a planet living too close to the machinery. Venus would be more deceptive, and that deception is what makes it unsettling. From space, Venus is beautiful. Pale clouds cover the planet completely, reflecting sunlight so well that Venus becomes one of the brightest objects in Earth's sky. It looks smooth, luminous, almost peaceful. The surface tells another story, although you cannot see it directly with ordinary eyes. Beneath the clouds, the air is heavy enough to crush. The heat is high enough to melt lead. The clouds contain sulfuric acid. The planet rotates so slowly that its day lasts longer than its year. A place that looks soft from above becomes almost impossible at ground level. Radar has shown us the hidden face under the clouds: volcanic plains, highlands, impact craters, and landscapes buried beneath an atmosphere that acts like a lid. Venus does not simply have bad weather. It has an entire sky that hides the planet from view. That is what makes Venus uncomfortable. It is not some exotic world on the edge of the galaxy. It is nearby. It is rocky. It is close to Earth in size. On paper, it should feel familiar enough to comfort us. Instead, it becomes a warning. A planet can be Earth-sized and still be unlivable. It can shine beautifully while hiding a surface where machines fail, metals soften, and pressure turns atmosphere into punishment. The most frightening thing about Venus is not that it is alien. The frightening thing is that it almost seems like it should not be. Turning back toward Earth after Venus would feel different. The blue world would no longer look normal. It would look unlikely. Open oceans, moving clouds, a thin atmosphere that is thick enough to breathe, but not so thick that it crushes the ground. A magnetic field helping protect it from the solar wind. A surface where heat has not run away into furnace conditions, and cold has not locked everything into permanent stillness. Earth is not special because it sits at the center. It clearly does not. The shock is that Earth is not at the center, and still became this. After the furnace of Venus and the exposed rock of Mercury, home would look like a balance that could easily have gone another way. Leaving Earth's orbit again, Mars would slowly become more than a reddish point. Mars is often called dead, but that word is too flat. A dead thing can be boring. Mars is not boring. Mars looks like something happened to it. The surface is covered in evidence. Dry channels where water may once have moved. Minerals shaped by ancient wet conditions. Polar caps. Dust storms. Volcanoes so large they make Earth's mountains feel temporary. A canyon system that cuts across the planet like the crust once opened under stress too large to hide. If you arrive near sunset, Mars might surprise you with color. On Earth, sunsets often turn red because our atmosphere scatters sunlight in a certain way. On Mars, the dusty atmosphere can make sunsets appear bluish near the sun. A red planet can have a blue sunset. That is the sort of detail that makes Mars feel less like a symbol and more like a place. Olympus Mons would not look like a normal mountain if you came close. It is so broad that the slope could hide the fact that you were climbing anything at all. The volcano is less like a peak and more like a region of the planet that slowly rose into a giant shield. Valles Marineris, the giant canyon system on Mars, would be even harder to process. It stretches thousands of kilometers. Put it on Earth, and it would cross a huge portion of a continent. From above, it would not feel like scenery. It would feel like a planetary wound. Mars keeps asking the same question without ever saying it. What changed? Why did this world, so near Earth, become so cold, dry, and thin-aired? The answer is not one dramatic event. It is size, time, atmosphere, internal heat, magnetic protection, solar wind, and the slow loss of conditions that once made the planet more active. Mars may have had rivers, lakes, and a thicker atmosphere long ago. It may have been a more complicated world than the dry red planet we see now. Smaller than Earth, it cooled more quickly inside. Its global magnetic field faded. The atmosphere became more vulnerable to erosion by the sun's charged particles. A planet can lose the conditions that once made it promising. That is the part Mars makes hard to ignore. It is not only a destination for future astronauts, it is a reminder that a world can have a past more generous than its present. Beyond Mars, the inner solar system begins to loosen. The sunlight is still strong, but the feeling changes. The rocky planets are behind you, and ahead lies a region many people imagine completely wrong. The asteroid belt would not rush toward you as a deadly storm of tumbling rocks. Most of the time, you would see almost nothing. That emptiness is the real fact. Even a place filled with millions of objects can be mostly empty because space stretches the meaning of filled beyond ordinary use. Spacecraft have crossed the asteroid belt many times without weaving through chaos. The objects are spread so far apart that danger is not visual in the way movies taught us to expect. If your path brought you close to an asteroid, the encounter would feel ancient rather than explosive. Some are rocky, some contain metal, some are loose piles of rubble held together by weak gravity. Many are leftover material from the solar system's formation, pieces that never joined a planet. Some asteroids are not solid boulders at all, but rubble piles. They may look like single objects from far away, while actually being collections of fragments gently held together. Land on one too carelessly, and the idea of ground would become strange. You would not be standing on a normal surface. You would be touching a small world barely holding itself together. Ceres would change the mood again. It is round enough to be a dwarf planet, large enough to feel like a small world, yet it lives among fragments. Bright salt deposits on its surface hint at a more complicated internal history than a simple rock should have. It is not a planet, but it is not just debris either. The asteroid belt is the solar system's unfinished business, a place where material gathered, collided, scattered, and remained in between. Not planet, not dust, not nothing. A memory of construction that never fully completed. Crossing it, you would leave behind the familiar architecture of rocky worlds. Ahead, the solar system stops pretending to be Earth-like at all. Jupiter would be waiting beyond the darkness, and it would be the first object that makes your ship feel small in a completely new way. Jupiter would not arrive like a normal planet. At first, it would be a bright point, then a disk, then something so large that your mind would stop treating it as a destination and start treating it as an environment. Near Jupiter, the word planet begins to fail. It is more like a gravitational empire. Everything around it is being negotiated by its mass. Moons, dust, trapped particles, radiation belts, magnetic fields, small bodies, future trajectories. Jupiter does not simply sit in the solar system. It alters the behavior of the region around it. Its clouds would fill the window in bands of cream, brown, orange, and white. They might look soft in photographs, but that softness would be an illusion created by distance. There is no ground waiting below the way there is on Earth. You would be looking into atmosphere layered over pressure, chemistry, heat, and motion. The Great Red Spot would be impossible to treat as ordinary weather. From far away, it is a feature dot. Up close, the scale becomes absurd. A storm large enough to swallow Earth has been watched by human beings for centuries. On our planet, storms break apart when conditions change. They meet land, lose heat, or collapse under their own instability. Jupiter has no solid surface to interrupt its storms in the same familiar way. Weather there can become historical. A storm can last long enough to become part of astronomy's memory. Jupiter's magnetic field would be even more unsettling because you could not see it. If it were visible from Earth, it would appear larger in our sky than the full moon. Around Jupiter, invisible structure becomes as important as the visible planet. Radiation trapped in that magnetic environment can be dangerous enough to threaten spacecraft electronics and human bodies. A calm-looking approach would not mean a safe one. Jupiter teaches that space does not need to look hostile to be hostile. Its moons would make the system feel even less like a single planet and more like a miniature solar system. Io would break the word moon almost immediately. Instead of a quiet gray companion, it is the most volcanically active world we know. Its surface is constantly changed by eruptions, lava flows, and sulfur-rich material. The energy does not mainly come from sunlight, it comes from gravity. Jupiter pulls on Io. Neighboring moons help maintain the orbital rhythm. The result is tidal flexing, a constant squeezing and stretching that heats Io from inside. That idea has a disturbing simplicity. A world can be tortured into volcanism by orbiting too close to something massive. Flying past Io, you might see volcanic plumes rising from the surface and spreading material into space. The moon would not feel dead. It would feel worked on, rewritten, kept restless by forces it cannot escape. Around Io's orbit, there is also a vast torus of charged particles, fed by material from the moon's volcanoes and shaped by Jupiter's magnetic field. In simple terms, Io is not only erupting onto itself, it is helping fill the space around Jupiter with electrically charged volcanic material. A moon becomes part of a planet's invisible weather. Europa would feel quieter, but the quiet would be suspicious. Its surface is pale ice, crossed with cracks and reddish lines. It does not advertise itself. There are no giant volcanoes shouting from the surface, no thick orange atmosphere, no rings, no huge storm. At first glance, Europa looks sealed. That is exactly why it matters. Under the ice, there may be a global ocean of liquid water. A moon around Jupiter might contain more liquid water than Earth's surface oceans, hidden in darkness beneath a frozen shell. No waves under sunlight, no blue horizon, no weather above it in the earthly sense, just pressure, chemistry, heat from tidal flexing, and a crust that may be hiding one of the most interesting environments in the solar system. Some regions of Europa's surface look broken and rearranged, almost as if slabs of ice shifted and refroze. Scientists call some of this chaos terrain, and the name fits. From above, it would look like the surface had been cracked, disturbed, and reassembled. Europa changes the meaning of a habitable world. A place does not need to look alive from outside. Its most important environment may be buried. Ganymede would look like another category problem. It is called a moon, but it is larger than Mercury. If it orbited the Sun instead of Jupiter, people would probably have no trouble calling it a planet. It even has its own magnetic field, which makes it unusual among moons. The surface carries dark ancient regions and brighter grooved terrain, signs that its history is not simple. Ganymede is not a small rock circling a planet. It is a major world caught in another world's empire. Callisto, farther out, has a different kind of force. It looks old, heavily cratered, less dramatically active, and covered in scars that have remained visible through immense time. Some worlds reveal themselves through motion. Callisto reveals itself through preservation. Around Jupiter, the neat classroom version of the solar system becomes almost useless. A planet can have moons that are larger than planets, moons with oceans, moons with volcanoes, moons with magnetic fields, and moons whose surfaces look like ancient records. The system is not one object with accessories. It is a whole neighborhood of worlds held under Jupiter's gravity. Leaving it would feel like leaving an entire chapter behind. Saturn would begin differently. Jupiter overwhelms by mass. Saturn disarms by beauty. At first, it might look too elegant to be real. A pale planet circled by rings so wide and clean that the eye wants to believe they are solid. That mistake would not survive close approach. The rings are not a platform. They are countless pieces of ice and rock, each one orbiting Saturn. Tiny grains, larger chunks, fragments, gaps, waves, edges shaped by gravity. From far away, motion blends into smoothness. Up close, the stillness breaks apart into structure. Their proportions are almost ridiculous. The rings are incredibly wide, yet thin compared with their diameter. A system that dominates the view is, in another sense, delicate. Crossing above the ring plane, you would see Saturn cut by light. Shadows from the rings would fall across the planet. Saturn's shadow would slice through the rings. Beauty would stop feeling soft and start feeling mechanical, cold, precise. Sometimes, spacecraft images have shown faint spoke-like features in Saturn's rings, temporary patterns that do not behave like ordinary solid structures. The rings are not just pretty bands. They are a changing environment where particles, gravity, sunlight, and electromagnetic effects all matter. Saturn is also slowly losing some of its rings. Material from the rings falls toward the planet in a process often called ring rain. The rings look eternal because human lives are short, but they may be temporary on planetary timescales. That makes Saturn more haunting. You are not looking at a permanent crown. You are looking at something spectacular that may not last forever. Then comes the hexagon. At Saturn's North Pole, a six-sided jet stream forms a huge geometric pattern larger than Earth. It looks artificial in the way only nature can look artificial, because no one designed it. Fluid motion, rotation, and atmospheric physics produced a shape that seems almost too clean. Saturn is not peaceful. It is organized strangeness. Titan would pull the journey in a different direction. Saturn's largest moon is wrapped in a thick orange haze, hiding its surface from ordinary view. A moon with a dense atmosphere already feels wrong. What lies below makes it stranger. Titan has weather, clouds, rain, rivers, lakes, and seas. The liquid is not water. It is methane and ethane, moving through the landscape under extreme cold. On Earth, water builds the familiar cycle between sky and ground. On Titan, hydrocarbons take on part of that role. The place feels almost Earth-like until you think about the chemistry. Shorelines exist, but not beside water you would recognize. Rain falls, but not rain that belongs to life as we know it. Rivers carve the surface under a sky so cold and orange that familiar words begin to feel borrowed. Because Titan has low gravity and a thick atmosphere, falling there would be strange too. Movement would not feel Earth-like. The world has enough atmosphere to feel like a place with weather, but not the kind of world your body was built to trust. Titan is not Earth's twin. It is Earth rewritten with the wrong liquid. Enceladus would seem modest after Titan, at least at first. A bright, icy moon, small enough to underestimate. Near its south pole, that impression changes. Geysers send water vapor and icy particles into space. The plumes likely connect to a hidden ocean beneath the crust. Instead of forcing scientists to drill through ice, Enceladus throws pieces of its interior outward. A spacecraft can fly through the plume and taste the chemistry of a hidden ocean. Water, salts, organic molecules. None of that proves life, but it makes the moon difficult to ignore. Something tiny and frozen is leaking clues. By the time Saturn falls behind, sunlight has begun to weaken in a way that feels more final. The inner solar system has dramas the human mind can grasp more easily. Heat, rock, clouds, red deserts, giant storms. Farther out, the cold becomes part of the story. Uranus would look calm from a distance, a pale blue-green world with a soft appearance. Its motion carries the shock. The planet rotates almost on its side. A tilt of about 98 degrees means Uranus rolls around the Sun in a way that makes Earth's upright rhythm feel ordinary by comparison. Seasons there are not a matter of a few months. One pole can face sunlight for years, while the other remains in darkness. And a season can last more than 20 Earth years. A whole generation on Earth could grow older during one season on Uranus. The tilt may be the result of a massive, ancient collision, although the details remain uncertain. That possibility gives the planet a hidden violence. Nothing in the calm, blue-green disk tells you directly what happened, but the rotation feels like evidence left in motion. Uranus looks quiet while carrying an old injury in the way it turns. Its rings are dark and narrow, nothing like Saturn's bright display. They would not announce themselves as a grand spectacle. They would appear more like a secret structure around a sideways planet, subtle and easy to miss unless the light and angle were right. Neptune would be darker, bluer, and farther still. At that distance, the sun no longer owns the sky in the same way. It shines, but it is small. The instinct is to imagine Neptune as sleepy, cold, and slow. Reality does not cooperate. Neptune has some of the fastest winds in the solar system. Despite receiving very little sunlight compared with Earth, its atmosphere moves with extreme force. Internal heat helps drive storms and clouds across a planet so distant that its weather feels almost defiant. Less sunlight does not mean less motion. A world can sit in the cold and still be restless. Triton, Neptune's largest moon, adds a final complication before the planetary solar system fades. It orbits backward compared with Neptune's rotation, suggesting it may have been captured rather than formed there. A stolen moon is an easy phrase, but the idea behind it is real enough to feel strange. Triton may once have belonged to the outer solar system as an independent icy body before Neptune's gravity took it. Now it circles a distant blue planet in the wrong direction, carrying signs of geological activity on its frozen surface. Its surface has strange terrains too, including areas sometimes compared to the skin of a cantaloupe because of their unusual texture. Even at the edge of the planetary solar system, the worlds are not simple ice balls. They have histories, surfaces, scars, and movements that refuse to be boring. By this point, Earth would be more than far away. It would be psychologically difficult to place. Somewhere behind you, near the sun from this perspective, the entire human world would be hidden among distances too large for instinct. The planets you passed would no longer feel like names in a school diagram. They would feel like different solutions to the same ancient beginning. The journey would not have shown a neat family of similar worlds. It would have shown how wildly matter can diverge once gravity, chemistry, distance, collisions, atmosphere, and time begin to work. After Neptune, it would be tempting to think the solar system is finished. That temptation comes from old diagrams. The real solar system continues, but it becomes harder to draw. Beyond Neptune, the solar system stops behaving like the clean model most people carry in their heads. The planets are behind you now, but the sun's family continues without offering a proper border. No wall appears in the darkness. No final gate waits beyond Neptune. Nothing suddenly announces that the solar system is over in a way your eyes would understand. It thins rather than ends. That may be one of the strangest things about traveling outward. The farther you go, the less the solar system feels like a place with an edge, and the more it feels like a fading influence. The sun is still behind you. Its gravity still reaches outward. Its light still crosses the darkness. Its particles still move through space. But everything is weaker now, quieter, more spread out. Pluto would be one of the first familiar names in that outer darkness, and if you saw it closely, it would not feel like a demoted planet dot. It would feel like a complicated little world that spent most of human history being misunderstood from too far away. For decades, Pluto was almost more idea than place. A small dot, a symbol at the edge, a name children memorized. Then spacecraft images changed the emotional weight of it. Pluto was not a plain frozen ball after all. It had mountains, plains, color differences, hazes, and a surface far more active-looking than people expected. From approach, Pluto would appear small but not simple. Mountains made of water ice rise above plains of frozen nitrogen. Some regions look smooth enough to suggest renewal, as if the surface has not been sitting unchanged since the beginning. The famous pale, heart-shaped area, Tombaugh Regio, gives the dwarf planet an almost emotional appearance, though the science behind it is physical, cold, and real. That contrast would be hard to shake. A heart-like plain on a frozen world billions of kilometers from Earth. The sun there would not be gone. That is the detail that surprises people. Noon on Pluto would be dim compared with noon on Earth, but the sun would still be much brighter than the full moon appears in our night sky. Distance does not switch daylight off all at once. It changes it slowly, until sunlight becomes something thinner, colder, and less familiar. If you stood on Pluto, the sky would not look like Earth's sky. There would be no blue overhead, no soft atmospheric brightness, no weather in the human sense. The sun would be a brilliant point, still powerful enough to matter, but no longer the overwhelming disk we know from home. That is what distance does to even the most important star in your life. It turns the sun into a point. Charon, Pluto's large moon, would make the scene even stranger. Pluto and Charon are tidally locked, so the same sides face each other as they orbit. From the right place on Pluto, Charon would hang in the same part of the sky without rising or setting, a moon fixed above the landscape. Human beings are used to skies that move. The sun rises and sets. The moon crosses the night. Stars turn overhead with Earth's rotation. On Pluto, the sky would have a different logic. A companion world could remain suspended in one place, always there, almost like a permanent witness. Pluto and Charon also move around a point outside Pluto itself. That makes the pair feel less like a normal planet and moon arrangement, and more like a double world, circling together in the cold. Traveling past them, you would begin to understand why the old version of the solar system felt too neat. Pluto was not the final dot. It was a doorway into a wider population. Beyond Pluto, the Kuiper Belt spreads outward, a vast region of icy bodies and dwarf planets left from the solar system's formation. It is tempting to picture a crowded, frozen field, but space resists that kind of imagination. Even here, among countless objects, the distances are enormous. Most of the view would still be darkness. That is difficult to accept because the human brain wants scenery. It wants a new object to appear every few seconds. It wants the outer solar system to behave like a museum hallway, with one frozen exhibit after another. A real journey would be much quieter. Long intervals would pass with nothing dramatic in the window. Instruments would detect more than your eyes could enjoy. Then, occasionally, a small world would become real. Eris would be one of those distant names that changed how people thought about Pluto. It is massive enough to matter, distant enough to feel almost mythological, and part of the reason scientists had to rethink the word planet. Haumea would be stranger in a visual way. It spins so quickly that it is stretched into an elongated shape instead of sitting as a calm sphere. A distant icy body can be deformed by its own rotation, as if motion itself has pulled the world out of roundness. Makemake would be another cold member of this outer population, bright with frozen material and moving through a region where sunlight has become weak but not meaningless. These objects do not feel like the main planets. They do not dominate the solar system the way Jupiter or Saturn does. But they matter because they reveal that the outer solar system is not empty. It is a cold archive of pieces that never became major worlds. The Kuiper Belt is not just a place beyond Neptune. It is memory preserved in ice. Material that formed in the young solar system still circles the sun out there, changed by time, but not absorbed into the big planets. If the asteroid belt feels like unfinished business made of rock and metal, the Kuiper Belt feels like unfinished business made of ice, distance, and weak sunlight. Some objects out there have moons. Some have unusual shapes. Some may carry frozen methane, nitrogen, or other volatile materials on their surfaces. Their chemistry is not loud from a distance, but it tells a quiet story about temperature, sunlight, and where in the young solar system different materials could survive. Closer to the sun, heat erased certain possibilities. Farther out, cold kept them. That is one reason the outer solar system is so valuable. It stores things the inner solar system could not keep in the same way. As you continued outward, The sun would shrink behind you, but its gravity would not simply stop. A star's control does not end where its light stops feeling warm. Far beyond the planets and dwarf planets, comets and icy bodies may still be loosely bound to the sun. Some of them come from the Kuiper Belt. Others may come from a far more distant region called the Oort cloud. The Oort cloud is different from the Kuiper Belt. It has never been directly photographed as a neat shell of objects, but it is thought to exist because of the behavior of long-period comets. These comets arrive from extreme distances and strange directions, suggesting that the sun may be surrounded by a vast, distant reservoir of icy bodies. If the Oort cloud exists the way scientists think it does, it may extend incredibly far from the sun, perhaps a significant fraction of the way to the nearest stars. That idea changes the solar system again. The planets are not the whole story. Neptune is not the edge. Pluto is not the edge. Even the Kuiper Belt may not be the edge. The sun's family may continue outward as a loose, almost invisible cloud of frozen bodies, so distant that the sun's gravity holds them only gently. Out there, a passing star or the gravity of the galaxy itself could disturb an icy object and send it falling inward as a comet. A comet in Earth's sky can look like a visitor from nowhere. In reality, it may be a returning piece of the solar system's deep storage. Imagine that from your ship. Somewhere in the darkness, an object that has spent millions of years in the cold might be nudged onto a new path. It begins falling inward. The sun grows brighter across its long journey. Ice that stayed silent for ages begins to warm. Gas and dust escape. A tail forms. Something that was once nearly invisible becomes a glowing sign in the inner solar system. The comet was not born when humans saw it. It was awakened. That is the kind of time the outer solar system keeps. Farther outward, even the sun's wind begins to matter in a different way. The sun does not only shine, it also sends out a flow of charged particles called the solar wind. That flow creates a vast bubble around the solar system called the heliosphere. Inside that bubble, space carries the sun's signature. Beyond it, the environment belongs more fully to the space between stars. You would not see the heliosphere as a glowing shell. No bright border would appear outside your window. The crossing would not feel cinematic. Instruments would notice changes before your eyes did. Particles, magnetic fields, plasma behavior, and cosmic rays would tell the story. That is one of the most humbling things about the solar system's edge. The important border is invisible. Human beings like edges they can see. Coastlines, walls, horizons, doors. But the outer solar system does not care about human categories. Its boundary is more like a change in influence than a physical line. The Voyager spacecraft have reached this distant region. That fact deserves a moment, because it is easy to say too quickly. Small machines launched in the 1970s traveled past the giant planets and continued into the darkness beyond. They are farther from Earth than any other human-made objects, still moving outward long after the world that built them changed around them. Think about what that means. A machine made on Earth passed Jupiter, Saturn, Uranus, and Neptune. It crossed beyond the main planetary system. It entered a region where the sun is no longer the same kind of presence it is near Earth. It kept moving after the people who designed it aged, retired, or died. It is still carrying traces of human intention into a darkness no human body has entered. Voyager does not move fast compared with the galaxy. Compared with light, it is painfully slow. Yet on the scale of human history, it is almost impossible to make anything feel more like departure. It is still leaving. It also carries a message from Earth, not because anyone expects a reply soon, but because humans decided that a small object leaving home should carry some memory of where it came from. That is strange in the most human way. We built a machine for science, sent it past the planets, and gave it a kind of greeting card for the universe. If your ship continued outward with impossible patience, The sun would shrink behind you until it became one bright star among many. That moment might be harder to accept than any planet. From Earth, the sun feels absolute. It makes day, warms the ground, grows food, shapes weather, and returns each morning with such reliability that people build their whole sense of time around it. Far enough away, even the sun becomes a point. Its importance does not shrink, but its appearance does. Space keeps separating meaning from size. Earth would disappear even sooner, not because it stopped mattering, but because it is too small and dim to stand apart from the distance. Every ocean, city, language, memory, and living body would be hidden on a world too faint to notice from far away. That thought can feel bleak at first. It does not have to stay that way. A thing does not need to be large to matter. Most meaning in the universe, at least as far as we know, happens in small places. A brain is small. A cell is small. A seed is small. A book is small. A sleeping child is small. A planet with life is small when measured against a galaxy, and still it can contain every question anyone has ever asked. Beyond the heliosphere lies interstellar space. It is not perfectly empty, but compared with anything familiar, it is almost nothing. Particles, dust grains, magnetic fields, cosmic rays, and traces of matter exist there, spread so thinly that ordinary experience has no useful comparison. A ship entering it would not feel like it had crossed into a dramatic new kingdom. The change would be quieter than that. The planets would be gone behind you. The sun would be a star. The next star system would still be terribly far away. Proxima Centauri, the nearest known star to the sun, is more than 4 light years away. Light itself takes more than 4 years to make that crossing. A human spacecraft would take far longer. That is where the scale of the galaxy finally becomes clear. Leaving the solar system does not mean arriving near another star. It means you have barely stepped off one island. Only from there does the Milky Way begin to feel real. Not as a bright band in the night sky, not as a name in a textbook, but as an ocean of distances so large that even the nearest stars are almost unreachable by human standards. A traveler might expect relief after escaping the solar system. Instead, the deeper truth would arrive. The solar system was not the universe. It was one small harbor around one ordinary star. Behind you, that harbor would contain everything familiar. The rocky planets close to the sun. A blue world with air and oceans. A dead moon that remembers footprints. A red planet with dried valleys and blue sunsets. A belt of fragments that never became a planet. Jupiter with volcanic Io and ocean-bearing Europa. Saturn with rings that may be temporary, Titan's methane weather, and Enceladus leaking clues from a hidden sea. Uranus rolling on its side with dark rings. Neptune moving under winds that should not feel so alive at such a distance. Pluto, with its fixed moon and frozen heart-shaped plain. Beyond all of that, small icy worlds, old comets, a magnetic bubble, and finally, the quiet beginning of interstellar space. This is the part where the solar system stops feeling like a list. It becomes a long transformation. Near the sun, matter became rock, metal, heat, atmosphere, and fragile blue stability. Farther out, the same early ingredients created giant planets, moon systems, rings, methane lakes, hidden oceans, captured bodies, frozen archives, and loose clouds of comets barely held by the sun. One young star formed with a disk of gas and dust around it, and time allowed that material to choose different futures. That may be the perspective that stays with you after the journey. The solar system is not a family because its members are similar. It is a family because they share an origin. Mercury's cliffs, Venus's sealed atmosphere, Earth's oceans, Mars's dry valleys, Jupiter's moons, Saturn's rings, Titan's lakes, Pluto's plains, and the distant comets of the outer dark all come from the same ancient beginning, shaped differently by distance, mass, collisions, gravity, heat, and time. Earth is not normal because the other worlds are strange. Earth is one strange result among many. It just happens to be the result you can breathe inside. Seen from far enough away, Earth would not look important. It would barely be visible. Yet on that small planet, atoms made in ancient stars became oceans, forests, instruments, language, memory, and minds capable of imagining the journey outward. You are not outside the solar system thinking about it from nowhere. You are made by it. The calcium in your bones, the water in your body, the air in your lungs, and the timing of your days all belong to the same larger history as Mercury's cliffs, Venus's clouds, Mars's dry valleys, Jupiter's moons, Saturn's rings, Titan's lakes, and Pluto's frozen plains. Right now, even if the room around you is still, nothing about your position is truly still. Earth is turning beneath you, while the moon drifts a little farther away with every year. The planet keeps falling around the sun, and the sun carries the whole system around the center of the Milky Way. Far from here, Jupiter is still shaping small bodies with its gravity. Saturn's rings are still moving in countless pieces. Neptune's winds are still crossing the cold, and Voyager is still leaving. Rest, from inside a solar system, is motion you have learned not to notice. So if you are listening at night, somewhere on Earth, you do not need to travel outward to belong to the journey. You are already inside it. The solar system is not above your life. It is the structure carrying your life. Let that thought become quiet now. The planets can drift back into darkness. The sun can become warm in memory instead of bright in your eyes. Earth can keep turning without needing you to hold it in place. For a while, the solar system does not need to be crossed, conquered, or fully understood. It can simply become a vast, moving place to rest inside.